In this video, we're gonna talk about the arc length. It's gonna be easier than the volume that we have been studying before. Okay, so the arc length is gonna be the problem that when you see the curve over the interval AB, before we try to find the area under this curve, okay, so before we do this, however, for this one, we like to know the distance. So we like to know the distance, so it's gonna be, we like to know the length of the curve. So you see that for this problem, you like to know the length of the curve instead of the area, instead of the volume or something. So in this case, we gonna use the Riemann sum again. However, we're gonna use the Riemann sum on the distance between 2 points on the curve. So you see that if I divide the interval AB into small pieces, you're gonna see the point on the curve P0, P1, P2, Pi minus 1, Pi, and so on until you have Pn is the function, the value of the function at D. So in this case, you're gonna sum the distance between these 2 points together. However, you may argue that, hey, you're gonna get some error, right? So here it's gonna be just the distance, it's gonna be just straight line. However, your curve is not straight line. What should we do with this problem? The thing that we're gonna do with this problem turned out to be, if you have the interval here very small, this guy gonna become very close to each other and it's gonna turn out to be equal to, okay, in the concept of limit n go to infinity. So that will be the thing that we shall use. So the distance from xi minus 1, fxi minus 1 to xi, fxi turned out to be just the first coordinate, subtract each other square, plus the second coordinate, subtract each other square. So you have xi minus 1 square plus fxi minus fxi minus 1 square. And then you pull out xi minus 1, okay? And you would get 1 plus fxi minus fxi minus 1 over xi minus 1. So in this guy, you see delta x. So you see that this term turned out to be delta x. And you see what it look like here. So we have seen this guy before, fxi minus fxi minus 1 over xi minus 1. This guy look like slope, okay? So you see that the pink guy here turned out to be about f prime x. Okay, so the pink guy here turned out to be f prime x when delta xi small. Okay, so you have delta xi times this guy. Okay, so you see that the pink guy turned out to be f prime xi when delta xi is very small. So if this guy gonna go to 0, you see that it's gonna turn out to be derivative as xi. So in this case, it's going to be limit n go to infinity of the sum I equal from to 1 to n of square root 1 plus fxi minus fxi minus 1 over xi minus 1 square. And this guy turned out to be the slope. So in this case, okay, you get the slope square. Okay, you get the slope square. So you have integral from a to b square root 1 plus slope square dx. So it's going to be integral from a to b square root 1 plus y prime square dx. Okay, so this one will be the formula for arc length from a to b. Okay, so this is the thing that we are having, the arc length from a to b. Okay, so it's going to be LAB, the arc length from A to B. So you see that for this one, sometimes we not have to graph the function. It's a good advantage. So we don't know the graph of the function, the thing that is going to be just one formula, integral from A to B, square root 1 plus a prime x squared dx. Let's try to set up first. This question asks you only to set up, okay, ask you to set up So for this one, you don't have to integrate. You're gonna just set it up. So you have y equal to x squared. So the thing that you will need will be, you will need y prime. Okay, so the first step will be you need y prime. So you have y prime, it's going to be just 2x. Okay, quite simple. And for the second step, you're going to have L04. So it's going to be integrate 0 to 4. Okay, so it's going to be just like this. And you have square root 1 plus y prime square. And dx. So you just have indicate 0 to 4 square root 1 plus 2x square dx. And that's all. Okay, so this one will be just your final answer. The second one, you have y equal to x cubed log x, and you like to set up the arc length from 1 to 2 of this function. So in this case, you're gonna have y prime. Okay, so you have to use the product rule. So it's gonna be the first derivative of the second plus the second derivative of the first. So you get x squared plus 3x squared log x. Okay, so it's going to be x squared plus 3x squared log x. So this one will be the y prime. Okay, and then you're gonna just have the formula. So you're gonna have L12 equal to integrate from 1 to 2. So square root 1 plus x squared plus 3x squared log x squared, and you have dx. Okay, so this one will be L12, and that's it. You don't need to expand, you don't need to simplify, because this question asks you to set up. So the setup thing is going to be just ask you to answer in terms of definite integral like this one. Okay, so you don't need to integrate for value. The next example will ask you to integrate for value that I'm going to show you how to do. It's going to be find the arc length of the curve. You have y equal to 2x to the 3 half. Okay, so this one you get fx equal to 2 to the 3 half. Okay, so we're gonna find the arc length for this one. So you first have to set up the integral. So you have y prime. Okay, so you're gonna have y prime. Y prime in this case is gonna be, you have 2 times 3 half x to the 1 half. Okay, so this guy turned out to be 3 root x. Okay, so you have y prime equal to 3 root x. And you're gonna set up the integral. So it's gonna be L03. Okay, so you know that it's gonna be x between 0 and 3, right? So it's gonna be integral from 0 to 3. Okay, and you have square root 1 plus the y prime. So it's gonna be 3 root x square dx. Okay, so you see that I put y prime in the place that you have here. Okay, so that will be just set it up. Okay, and then what? And then we're gonna integrate this guy. So we're gonna integrate 0 to 3 square root 1 plus 9x dx. Okay, and you're gonna use substitution. So you're gonna let u to be 1 plus 9x. So you have du equal to 9 dx. Okay, and you're gonna have x equal to 0, u equal to 1, x equal to 1, u equal to, not x equal to 1, x equal to 3, u equal to 28, right? So you have this one, and you're gonna change, or you're gonna substitute. So it's gonna turn out to be integrate from 1 to 28, right? Square root u. Okay, so this guy is equal to u. Okay, so this guy is equal to u, and you have du, which is dx. So in this one, you would get dx. Okay, so du is 9 dx. So you're gonna get dx equal to what? Equal to du over 9. Okay, so it's turned out to be du over 9 for dx. So in this case, you're gonna just integrate u to the 3/2. So it's gonna be u to the 3/2 over 3/2 from 1 to 28. So it's gonna be 2/3, okay? And it's gonna be 28 to the 3/2 minus 1 to the 3/2, okay? And you forgot 9, okay? So it's gonna be 1 9 outside, okay? So this one, I gonna get 2 over 27, okay? So that's all for this arc length. You see that it's easy setup, and it's going to be integration using the substitution that you have to use algebra. So I'm going to consider this guy into two steps. The first one is you find derivative, and it's going to be the first step is be setting it up. So this one will be set up. The second one will be you're gonna evaluate for value. So here you use algebra and the substitution. Okay, so that will be the algebra and the substitution. So this one will be your second step. That's all. You have y equal to log psi x. Okay, you have y equal to log psi x, and you have x between pi 6 to pi quarter. So for this one, you're gonna have y prime. Okay, so you have y prime. You dip log psi is gonna be 1 over psi x, and you have cosine x. Okay, so this one, so it's gonna be cot x. Okay, so it's gonna be cot x, and you're gonna have L pi 6 to pi quarter. So it's going to be integrate pi 6 to pi quarter of square root 1 plus y prime square, right? Let me write down the formula first, dx. So you get integrate pi 6 to pi quarter, square root, okay, 1 plus cot x square dx. And for this one, you see that it seems difficult. However, if you recall trigonometric identity, you have 1 plus cot x squared. Okay, so you have 1 plus cot x squared turn out to be cosec square x. So for this one, it's going to be very, very simple. So it's going to be cosec square inside. Okay, and you have integrate pi 6 pi quarter dx. So you get cosec x, okay, and you integrate from pi 6 to pi quarter dx. So in this case, you would have integrate cosec. It's gonna be log of cosec x minus cotan x, okay. It's going to be from pi 6 to pi quarter. and you're gonna just plug in for value. So it's gonna be absolute cosec pi quarter minus cot pi quarter minus log absolute cosec pi 6 minus cot pi 6. Okay, and you're gonna evaluate for value. So cosec pi over 4 is gonna be cosec of 45 degrees. So it's gonna be square root 2. Cot pi over 4 is gonna be 1. And you have cosec pi over 6 is gonna be 30 degrees, right? So it's gonna be 2. And cot pi over 6 is gonna be root 3. So you see everything turned out to be very nice. Okay, so it's going to be square root 2 minus 1 minus log of 2 minus root 3. And this one will be your final answer. So you see the whole question here that it's going to be set up. Okay, so the first step is going to be setting up. And you're going to use algebra here. So you see that it's not going to be the substitution anything. Sometimes it's going to be just using algebra for trigonometric function, and you're going to just be able to evaluate for value. Okay. The next one, you have y equal to x squared minus log x over 8 and x between 1 to e squared. Okay, so you have y equal to x squared minus log x over 8, and you have x between 1 to e square. So in this case, you're gonna have to compute y prime, okay? So you get y prime, in this case, you get 2x, and you get dip log, it's gonna be careful, this one, it's gonna be 1/8 first, and you dip log, it's gonna be 1 over x. So you have 2x minus 1 over 8x. Okay, so that's my y prime. And you have to find one. Okay, so let me consider this one separately first. So we're gonna consider 1 plus y prime square. Okay, so you consider 1 plus y prime square. And you have y prime is the green guy. So it's gonna be 1 plus the green guy square, which is 2x plus 1 over 8x square. Okay, and then you simplify this one, so you would get 1 plus, and here you have 4x square plus 2x 1 over 8x. Okay, and you plus 1 over 8x square. Okay, so this guy, you see that it's going to be, let me write this one in terms of 2x squared, because I'm not going to compute this one explicitly. So the thing that important for this question will be you just leave something like this first. So you just expand this one out, and you're going to have to notice that for this one, okay, for this one, it's turned out to be something nice. So you see that you'll be able to cancel. You would get 4 for this term. And you also see that this guy, okay, turned out to be equal to 1/4. Okay, so the whole term turned out to be equal to 1/4. Let me circle this one a little bit. So you would get the whole thing here. Okay, so the whole term here turned out to be equal to 1/4. Okay, so you're gonna see that this one will be, I make a mistake here. It's gonna be negative, right? So it's gonna be negative, sorry. So you get negative, okay? So please correct this one to negative for me. So you would get 1 plus 2x squared minus 1/4. Okay, and you're gonna add by 1 over 8x squared. And you can see that this 1 and 1/4 can be combined together. So you would get 2x squared plus 1/4 plus 1 over 8x squared. Okay, so this one will be 2x squared plus you get 1/4, so it's gonna be 2x 1 over 8x, okay, plus 1 over 8x squared, okay, and then this guy turned out to be 2x plus 1 over 8x squared. Okay, so that will be your 1 plus y prime square. Why do I need this? Because you're gonna find the arc length by the formula L of 1e square. Okay, so it's gonna be too dark. Let me use this one lighter. L1e square. So this one will be integral from 1 to e square of square root 1 plus y prime square dy, dx. Okay, and then you have integral from 1 to e square of square root 2x plus 1 over 8x square dx. And for this one, you see that it's going to turn out to be integrate 1 to e square, and you see square root and square, they cancel each other. So you would get only inside. So you get 2x plus 1 over 8x dx. And you get integrate 2x, you get x squared, integrate 1 over 8x, so it's going to be 1 over 8 log x from 1 to e square. So you get e square plus 1 over 8 log of e square. So this is one term minus 1 square plus 1 over 8 log of 1, the second term. Okay, so that's all. So you basically obtain e to the fourth, okay, and you have 1/8 minus 1 because log 1 equal to 0. And don't forget that this one is log e square. Log e square, you're going to move 2 in front. Okay, so it's going to be 2 log e, and it's going to be equal to 2. So I would have 2 up here. Okay, so I would have 2 up here. So in this case, you would have your final answer, e to the fourth minus 3/4. Okay, and that's it for this example. So you see that it's going to be kind of using algebra a lot. Okay, so here we not use substitution at all. We just play with algebra only here. So here you use algebra and you just have the basic integration. So you have cal here. Okay, so you have cal only the integration at the end. Okay, so this one is the, sometimes it's difficult for doing arc length. It's not from graphing. It's going to be from the algebra that is sometimes complicated in order to set up the term ready for you to integrate. Okay. Last one, you see that it's going to be kind of big here. You have fx equal to sine x over 4 minus log secant plus 10. Okay, and you need to find derivative. It seems hard to find derivative for this one. Let's try to find it first. So you have f prime x So you need to dip side, it's going to be cos x over 4. And you dip log sec plus tan. If you recall, you dip log sec plus tan, some of you may just, hey, it's going to be sec because you integrate sec, right? So in this case, this one will be what? Will be sec x plus tan x, okay? And you dip sec plus tan, you get sec x plus dip sec, you get sec x tan x, okay? And dip tan, you get secant square. So in this case, you would have, let me differentiate this one here. So you get cos x over 4 and you pull out sec x. So you get tan x plus sec x, okay, over sec x plus tan x. And for this one, you're gonna get rid of sec plus tan. So this one will give you cos x, okay, over 4 minus secant x that you have left up here. Okay, so you have cos x over 4 minus secant x. Yeah. So the thing that I want you to notice will be this guy can be written as cos x over 4 minus 1 over cos x, okay? Sec x is 1 over cos x also. So for this derivative, after you have this derivative, you're gonna find 1 plus phi 1 plus f prime square. Okay, so it's gonna be 1 plus cos x over 4 minus 1 over cos x square. Okay, and then you're gonna have 1 plus, so you need to expand this guy out, so it's gonna be cos x over 4 minus 2 cos x over 4, 1 over cos x plus 1 over cos x square. Okay, and for this one, the thing that I want you to see will be you'll be able to get rid of cos and cos 2 and 4. So it's going to be 2. And you see that you end up with 1/2 for the middle term. Okay, so this guy is just equal to 1/2. And the rest of the term, you just have 1 over cos x square. And you have cos x over 4 square. I forgot square, right? So it's going to be square. I have square. And this is the term that you have. And then you have 1 plus. Okay, so you have 1 plus cos x. Okay. So in this case, you get 1 plus this one, and you see that you'll be able to combine every term. So you get cos x over 4 square, and you see that you can combine 1 and 1/2 together to be. So this guy is gonna be what? 1/2 in the middle. Okay, and you're gonna have 1 over cos x square. Okay, so this guy is your yellow guy. And then what? And then you see that we're gonna go back to this term here. So this guy is equal to 1/2 before, right? So this guy is equal to 1/2. Okay, so this 1/2 turned out to be 2 cos x over 4, and you have 1 over cos x. Okay, so that my 1/2, and you have 1 over cos x square, and you have cos x over 4 square. Okay, so this is what you have. And so you get cos x over 4 plus 1 over cos x square. Okay, so this one is 1 plus f prime x square. So it's going to be cos x over 4 plus 1 over cos x. And then we're going to find the arc length. I'm going to use the other side. So for the arc length, I would set up L0 pi over 4. So it's going to be integral from 0 to pi over 4 of square root 1 plus the derivative that you have. Okay, so you're gonna copy this guy. So it's gonna be here that I'm gonna put the derivative. So you have this term and you're gonna square it. So you get this guy. So you get this guy square. So you get this one. And you see that this guy turned out to be square root of, I'm going to copy this term. Okay, the thing that we already simplify. So it's going to turn out to be this one. Okay, and you see, I have everything set up nicely like this. And then you see that it's not hard to integrate right now. So it's going to be integrate 0 to pi quarter. And you see that you have only the red guy inside left. And 1 plus cos is going to be sec x. Okay, so 1 plus cos x is secant x. And then we're going to integrate. So it's going to be 1/4, integrate cos, it's going to be psi, integrate secant, it's going to be log absolute sec x plus 10x. Okay, and it's going to be from 0 to 1/4. Not 1/4, pi quarter. So this would be 1/4 psi pi over 4 minus psi 0. Okay, and you add by log of secant pi over 4, right, minus 10 pi over 4, and you have minus log of sec 0, 10 0. Okay. Finally, you have 1/4 psi pi over 4 equal to 1 over root 2 or root 2 over 2, psi 0 equal to 0. Okay, sec pi over 4 is root 2, tan pi over 4 is 1, and sec 0 is 1, tan 0 is 0. So in this final answer turned out to be just root 2 over 2. Okay, and you have plus log of absolute root 2 minus 1. Okay, so it's gonna be root 2 over 8 plus log absolute root 2 minus 1, and that will be your final answer. Sec, sec plus 10, right, so sec plus 10, sorry. So it's gonna be root 2 plus 1 instead. Okay, so it's going to be log root 2 plus 1, okay, so by root 2 over 8. So you see, this is the end of the application of integration. It's going to consist of 3 topics: area, volumes, and the arc length. The arc length will be the one that you don't have to graph anything. However, the difficulty for this arc length turned out to be on substitution or on algebra. So you see that we did many algebra here in order to be able to integrate at the end. So you see that the part that you use cal is going to be here, okay? And here is going to be just pure algebra. Okay, so you use algebra a lot here, and you just use cal one line. Okay, however, this one is the calculus technique in order to find the distance on the curve. Okay, that will be important. Okay, so I'm gonna stop here, and that will be the end for this chapter. We're gonna continue the next chapter about the technique of integration, and it's gonna be a lot of algebra involving in that chapter.